All right, this says day 2, it's actually day 3. We are going to find inverse trig values on the calculator, and it always seems like a relief when we finally get to do things on the calculator, but just like last unit, there's a lot of problems. You need to make sure you're in the right mode. You need to make sure you do your reciprocal functions correctly. So there's a lot going on here, and I find that it seems to be one of the areas where a lot of mistakes are made on the test, so just be careful. All right, so for the three main functions, sine, cosine, tangent, the inverse functions are pretty straightforward. You hit your second sine, cosine, or tangent to bring up the reciprocal function, put in the ratio that you're looking for, and make sure you're in the right mode. So for degree mode, inverse sine of 0.8, you're going to get your answers in degrees, so you do have to be careful you're in the right mode. And you can probably tell, well, we're going to get to that at the end of the lesson, but just do kind of a sanity check of your answer. 53.1 looks more like something that's degrees because it's a larger number. Remember, principal value is going to be from 0 to 360, less than 360 actually. So the largest number in degree mode you're going to get is 359.999. In radian mode, it's going to be 0 to 2 pi, and if pi is 3.14, 2 times that is going to be 6 point, let's say 3.2. No, it's going to be less than 6.4. So if you're in radian mode and you get something bigger than 6.4, you probably guess you're not in radian mode. So that would be one way to check things. All right, so those are the primary. What about the reciprocals? Well, for a regular trig function, if we want sine of 30, we put sine of 30. If we want sine of cosecant, we put 1 over sine of 30. It's a little bit different with reciprocals, and this is where the confusion comes, because you remember this. This is how you do it with reciprocals. Whoops, sorry. We're in radian mode first before we get to the reciprocal. So radian mode, you just need to make sure you're in the right mode, and you can see sine of 0.8. You're going to get, in general, smaller answers because radians are kind of bigger chunks. All right, so and again, in the question, it will tell you whether you should be in radian or degree mode. You can't tell otherwise, so just carefully read the instructions. All right, now we are going to get to reciprocals. So for cosine, secant, cosecant, secant, and cotangent, you are going to put it in like this. So inverse cosine of 2 is going to be inverse sine of 1 over 2. So the reciprocal actually, it goes inside the function, not outside. So remember, sine of 30 and then cosecant is equal to 1 over sine of 30. Here, sine of 0.5, inverse sine of 0.5, cosecant is going to be inverse sine of 1 divided by 0.5. So it is confusing because the reciprocal is different than from the normal, so just be very careful. All right, so that is one little trick you have to be very careful of. And other than that, you need to make sure you're in the right mode. And here's in radian mode. So that's one thing. The other little problem, it has to do with cotangent. So remember, we're using cotangent by finding we're using inverse tangent actually to find cotangent. But if you remember, the negative values for inverse tangent come here. So when you use this function to find cotangent, you're going to get an angle here, and we really want an angle in quadrant 2 because that's where the principal value comes from. So what do we have to do to change this angle into one that would actually be in quadrant 2? Well, all these angles are exactly 180 degrees apart from each other. So if this angle is negative 30, which is going to be 330, if I subtract 180 from it, I'm going to get, what am I going to get? 150, and that's going to be my angle, principal value angle that I should get for cotangent, inverse cotangent. So you're not done, and it's only in the case where you have a negative ratio. So if it were inverse cotangent of 1, you don't have to do it. Inverse cotangent of -1, you do, because of this discrepancy of where tangent and cotangent get their angle. Inverse cotangent and tangent get their angles. So I'm kind of explaining what I put here. When calculating the negative ratios for inverse cotangent, so notice this is the key word, negative. So it's only if the ratio that you're putting into the function is negative. You have to add pi if it's in radian mode, or 180 degrees if it's in, and it says add, it's because instead of getting 330, you're going to end up getting -30, I believe. So you're going to add the 180. And this is what I explained to you. This is because inverse tangent is used to find inverse cotangent, though they have different restrictive ranges. So here's an example. Inverse cotangent of -2. In degree mode, you're going to end up getting the negative 26.56, and you can see it right here. This is obviously this angle down here, -26. So your reference angle is 26.57, let's say. So we want to translate this back here. How do we do that? We're going to add 180 to it, and you're going to end up with an actual angle in degree mode of 153.44. So I would, in my calculator, I'd probably just do it like this. Inverse tangent 1 divided by -2 plus 180. And then you're going to get the best precision. In radian mode, so if I wanted inverse cotangent of -2, again, here's how I put it into my calculator. This is my value. This is going to be in quadrant 4. And so again, what I would probably do, and so I took this, rounded, and added pi, I'd probably just enter this into my calculator. That would be the most efficient way to do it. And you're going to get your answer. And depending on how you're supposed to round, or what level you're supposed to round to, this one is rounded to the 1,000th. All right. Evaluate each expression in degrees, minutes, and seconds. So for these, you're going to get an angle, and I'm going to want you to translate the decimal into minutes and seconds. So I'm going to show you how to do that. So here's an example. First of all, make sure you're in degree mode, inverse sine of 0.61. So I'll put that into my calculator, and I get 37.58965 degrees. So clearly the degrees is going to be 37 degrees. How are we going to find the minutes and seconds? Well, we're going to take the decimal part, and we're going to multiply that by 60 to get our minutes, and it's going to be 35.37 minutes. So in this case, we're going to take the part before the decimal, and that's going to be our minutes. And then to get our seconds, we take the decimal, what's left over from the minutes, the 0.37, multiply that by 60, and this is going to be our seconds. Don't worry about the decimal. If it's 5 or more, you're going to round this up. 5 or less, we just truncate it. So then that's going to end up as 22 seconds. So that's how you evaluate in degrees, minutes, seconds. All right, last thing is you're going to get some problems, and you're supposed to figure out whether they're in radians or degrees. So the inverse sine of 0.33 is 19.27. So as I said at the beginning, you know that your radians are going to be less than 2 pi, which is less than about 6. This is not less than 6, so it's positive. That means it's going to be in quadrant 1. So you're not going to have a radian answer in quadrant 1 that is this large, so it's going to be degrees. Inverse cosine of -0.22. So inverse cosine comes from quadrant 2. If it were in degrees, 1.79 degrees is here somewhere in quadrant 1. So this obviously doesn't come out of quadrant 1. It should come out of quadrant 2. So it has to be in radians. Okay, inverse sine, negative 6.89. So again, this is coming out of quadrant 4. It's larger than it's larger than 6 barely, but it's gonna be in degrees because this number is a little bit bigger than it should be if it were radians. All right, I think that is the whole lesson. So there'll be a worksheet. Bring any questions to class.